Here's a quick introduction to something called standard deviation, along with another vocab word we'll learn today called variance. And this is just going to be almost the calculation part of it. And then when we are together in class, we'll talk about more of the side of what does this mean, how do I use it, and things like that. So we are actually moving into measures of spread. So if you remember your acronym SUCS, this is the last one, spread, how far apart is the data, and measuring it with the standard deviation is one way to do that. A quick bit of notation before we begin. X bar, it's an X with a bar above it, is the sample mean. So when you have a sample and you've taken the average, you've taken the mean, we denote that by using the notation X bar. Okay, so you'll see that we're going to use that notation here today. Okay, so variance is the average squared deviation. And what you'll see kind of later in this video is that it has no practical meaning. You would never use variance. It's not an actual thing. It's just something we use to get to the standard deviation, which is the item that we actually care about. Here's the really long formula for variance. Sx squared is going to be our notation we're going to use today. Sx is the notation for standard deviation, and it's squared, the average squared deviation. So make sure you have this formula written down. What you'll see here in this formula is what we're going to do is we're going to take every item in our sample, and we're going to subtract off the mean. X bar stands for mean, and then we're going to square it. And then we're going to take the second item in the sample. We're going to subtract off the mean, and then we're going to square it all the way until the last item in the sample, subtract off the mean and square it, and then we're going to divide by n minus 1 when we're done. Okay, so we're going to do that here in a second. Let's talk about standard deviation. Standard deviation tells us, on average, how far away are the values from the mean, from the center. So mean is a measure of center, and spread is how far away we are from the mean. So standard deviation is going to tell us, on average, if here's my mean, approximately how far apart are my values from that mean. Are they really spread out? Are they really close together? That's what the standard deviation is going to tell us. So to find the standard deviation, we're just going to take the square root of the variance. So sometimes you'll also see it written, I don't think I have it on there, just the square root of the variance of x. Sometimes we use that notation too. All right, so let's calculate a standard deviation. So here's some data on how many pets people own, and we want to find the standard deviation. Okay. So this is going to be where we're going to put our answer over here at the end. So let's ignore this for a second. Somebody owns 1 pet and somebody owns 9 pets. And then we have this beautiful little chart here. So what I like about this chart is it kind of starts to show us what does a deviation mean. And it has already calculated out x bar for us. There it is. So x bar is 5. That's the mean is 5. And here's all of our data on there. You can see the little dot plot. And the deviation just tells us how far away are these values from 5, which is the mean. So let's calculate that. Okay, it's going to be a little bit tedious, but we can handle it. So I already have put our observations on there for us. And the first thing we want to find is just the deviation. How far away is this guy from the mean? So we know that x bar is 5. That's the average. If you were to take the average of those numbers, you'd get 5. So let's take 1 minus 5, which is -4. Okay. Over here we have 3 minus 5, which is -2, and so on and so forth. So let's go ahead and fill those in. Okay, so you'll notice that the observation of 5, which is the mean, it has a deviation of 0 because it is exactly on the balance point, the mean, the average of that data. 1 has a deviation of -4 because it's -4 below the balance point, below the mean. Okay, so take a second, either type these in your calculator or just do the math really quick. Add these numbers up and let's find the sum of all of these. The sum is 0. So that's kind of interesting. Basically what's happening here is we've got all of our deviations, we've added them up. Well, all of them should add up to the balance point because we should have the same number of observations below the balance point as we have above the balance point. So the sum is 0. This is the reason why we have to square them in order to find out anything interesting. Because a 0, it's going to be 0 for every sample. That's not going to be helpful to me. That doesn't tell me how far away things are from the mean. So instead, let's find the squared deviation. All of these will become positive numbers, and when we add them up, we'll have something that's actually useful to us. So let's go ahead and square all of these numbers. Okay, and add them up. Sum should be 52. Okay, so this is actually something I can use. So if you'll kind of think with me for a second, let's say we had somebody who had 20 pets. They're all the way over here at 20 pets. Well, their deviation is going to be quite large, and that's going to increase this number by a lot, okay, because they're a lot further from the mean. If we had just a bunch of people who were centered right here around 5, this number would not be very big. And so we kind of can start to see the bigger this number is, the further away our values are from the center point, that mean balance point. Okay, so let's find some answers here. So the average squared deviation. Okay, we've already squared our deviation. So now we're going to come back to our formula up here where we divide by n-1. So let's take 52 over n-1. We have 9 observations here, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's n, which is equal to 6.5. Remember that we squared things. So the units on 6.5 is squared pets. I don't know about you, but squared pets is pretty meaningless to me. I don't really care about how many squared pets you have, or pets squared. I care about how many pets you have, or how far on average we are away from our average pets, not pets squared. So let's find the standard deviation, which is going to be the square root of 6.5. And since we've taken the square root of pets squared, we have just pets. So this is something I actually can interpret. 2.5 pets, that means something to me, whereas 6.5 pets squared doesn't mean anything to me. Here's our interpretation. The number of pets owned is on average, and we'll throw our 2.55 number in here, 2.55 away from 5 pets. Okay, so we think, we can get the average. The average was 5. So if someone came up to you and asked, hey, on average, how many pets does this sample own? You could say 5. But if they wanted to know how much does the data deviate from 5, how far away is it from 5? Well, now you want to give them the standard deviation, which is, well, we're approximately 2.6, 2.55 pets away from this value. So, I mean, you would expect anywhere from, you subtract it, you add it, and it's going to be approximately 2.55 away. We'll talk more about using this number, again, like I said, later. So for now, this is a lot of work, right? And if your data points get a lot larger, you've got a decent amount of work to do, okay? But having a chart like this is helpful, and that's going to be the way we're going to do it. Okay, so let's go to the next page. You will see another big box. So it's the box that has these double lines around it. And that means that this is something we're going to use a lot. The good thing about interpreting a standard deviation is you can use the exact same wording every time. So We used this wording on the last page. Anything that's in bold is something you're going to have to fill in. So we said, excuse me, we said the number of pets, which is the variable in context, is on average 2.55. We could have said 2.55 pets. I guess we could add that. Away from 5 pets. So I'm going to recommend that every time you need to interpret a standard deviation, you use this wording. As you start to understand standard deviation more, you'll start to see that there are really other ways to interpret it. This way will get you full credit on a College Board test. So that's why I just suggest that you find one way you like, you interpret it the same way every time to not confuse yourself. Maybe you forget a part, but this is what I'm going to suggest that you do each time. Okay. And like I said, we'll start to understand more about what does standard deviation mean. Once we can actually get our hands on some data, we can manipulate it. And it's more than just kind of looking at it here. Okay. So for now, just know that this is how we will interpret it. And then we'll start to, okay, what does it actually mean? We'll get that when we see each other in class. Okay. I want you to try this example here. This gives you all the information that you need. The number of classes a senior at FHS takes is approximately normal. You can ignore that part. We don't really know what that means yet. With mean of 6.7 and standard deviation of 1.2. Now interpret the standard deviation. So if you think about what seniors take at FHS, a lot of seniors take flex periods. So it's not necessarily that they're taking 7 classes. Also, you know, sometimes you'll have a study hall or something like that that doesn't count as a true class in the eyes of Fishers High School. So that's why this is not 7. And then they're going to deviate from 6.7 by a factor of 1.2 classes. Okay, so let's interpret it. Use this up here. So pause the video and fill it in, and I'll show you my answer here in a second. Okay, so I've just used the exact wording from above, the variable in context, number of classes a senior at FHS takes. Remember that we like to mimic the wording of the question. So number of classes a senior at FHS takes. You'll see it again right there. Is on average. Standard deviation is 1.2. Context is classes. Away from, the mean is 6.7 classes. So pretty straightforward, just plug and chug into the formula. Okay, that's a basic introduction of standard deviation.